Modern physics and systems theory examine how complex behaviors emerge from simple, interacting elements, paralleling the idea of monads in Leibniz philosophy dynamically representing the universe. Let's unpack the idea of monads in Leibniz philosophy and connect it to the concept of emergence in complex systems. Leibniz monads. In his philosophical system, Gottfried Wilhelm Leibniz proposed that the fundamental building blocks of reality are monads. These monads are simple substances. They are indivisible and lack spatial extension, unlike atoms in materialist philosophy. Dynamic entities. Each monad is imbued with internal activity or energy. They are not passive, they are inherently dynamic and self-contained. Perceptive. Monads have a capacity for perception, the representation of the universe from their perspective, and appetition, the drive to transition from one perception to another. Windowless. Monads do not interact causally with each other in the traditional sense. Instead, their relationships and harmony are pre-established by God in what Leibniz calls the pre-established harmony. Dynamic feature of monads. The dynamic nature of monads lies in their internal principle of action. Each monad is like a living mirror of the universe, representing all other monads in a way that aligns with its individual perspective. The universe evolves in each monad according to its internal laws, which reflect its own purpose and potential development. Leibniz describes this as a kind of unfolding. A monad doesn't merely exist, it expresses itself dynamically over time, transitioning through a series of perceptions. This internal dynamism is intrinsic and predetermined by the initial conditions set by God. Emergence in complex systems. Emergence in complex systems refers to how intricate patterns, behaviors, or structures arise from the interactions of simpler components without any centralized control. Examples include flocking behavior in birds. Coordinated movement emerges from simple local rules followed by individual birds. Brain function. Consciousness and cognition emerge from interactions between neurons. Self-organization in ecosystems. Species interactions create stable yet dynamic systems. Parallels between monads and emergence. Individuality and unity. Just as monads individually reflect the entire universe, components in a complex system contribute to a unified global behavior. Internal dynamics. Monads evolve due to their internal principles, akin to how the behavior of system components is driven by internal rules, e.g., the chemical properties of molecules driving reactions. No direct interaction. Monads do not causally interact, instead, their harmony is pre-established. Similarly, in emergent systems, global order arises without direct coordination among components. Dynamic features of monads in context. The dynamics of monads can be seen as analogous to how a single component in a complex system follows its own program, yet contributes to the overall behavior of the system. Pre-established harmony is reminiscent of decentralized control in complex systems where local rules lead to emergent order. Individual perception of the universe mirrors the idea that each component in a system processes local information, which contributes to the global state. In essence, the dynamic feature of monads aligns with the principles of emergence, illustrating how independent, self-governing elements can collectively manifest a coherent and interconnected universe.